Hi everyone, my name is Dr. Teresa Chimambam. Today I will be continuing on our discussion on general inorganic chemistry. In the previous lecture, I talked about the different states of matter and I talked about energy. And I also discussed about the two major forms of energy. So, in today's lecture, I will be talking about mass and weight. I will be talking about quantities and units used in chemistry, and I will be talking about scientific notations. So we start with mass and weight. So mass is the amount of matter that is contained in an object. The amount of matter that is contained in an object is known as mass. Mass is always constant. Mass never changes. So if you are on Earth, your mass on Earth and your mass in space and on the moon will be the same. So mass is always constant, and mass is the amount of matter that is contained in an object. So now we'll move on to weight. Weight measures the impact or the effect of gravity upon an object. So weight is a measure of the effect of gravity on an object. And the formula for calculating weight is mass multiplied by gravity. So now we'll move on to quantities and units used in chemistry. So we start with units. Units enable us to differentiate between different types of measurements. Say, for instance, you measured weight, you need to specify whether it is in pounds or in kilogram. If you fail to specify the unit, that measurement would be meaningless because the person that is looking at the measurement will not know whether it is in pounds or in kilogram. If you measure temperature, for instance, you need to specify whether it is in Kelvin or it is in degree Celsius. If you measure your height, for instance, you need to specify whether it is in feet or meters. All measurements must have units. Any measurement in chemistry that does not have unit is meaningless. So we now look at acceptable units that are used in chemistry. So units, like I said earlier, are very important in chemistry. And the International System of Units, which is known as SI units, are used to present results in chemistry. So in chemistry, it is only the SI units that are used to present results. Say, for instance, if you measure length, length is measured in meter. So this is the acceptable unit. If you measure mass, mass is measured in kilogram. Kilogram is the SI unit of mass. If you measure time, time is in second. That is the SI unit. The SI unit of temperature is Kelvin. The amount of a substance is in mole. So these are known as SI units, and if you are presenting any chemistry results, you must use these SI units to present them. So now we move on to scientific notation. So, what is scientific notation? Scientific notation is a way of writing either a very large number or a very small number. So we use scientific notation to clearly express significant figures. The only thing you need to do is just to move the decimal. If the number is larger than 1, you move the decimal to the left. And if the number is less than 1, for instance, if the number starts from 0.000, you move the decimal to the right. If a number is smaller than 1, the original decimal point is moved S places to the right. The resulting number is then expressed as a multiple of 10 to power minus x. The exponent is the number of places you moved the decimal point. So let's have a look on this example. So for this example, you need to start counting like this. So this is 1, this is 2, 3, this is 4, this is 5, this is 6, this is 7, and you stop there. Then this will then be 1.23 times 10 to power minus 7. So we used negative sign here because the number is smaller than 1. So you can test your knowledge by trying to solve these examples. For instance, for number 1, you count 1, you count 2, and then you stop. So this will then be 7 times 10 to power 2. So try to solve the remaining 2 examples just to make sure that you have understood how to use scientific notation to express some numbers. So we now look at standards for measurements and their prefixes. So 1 is 10 to power 0. 10 is 10 to power 1 because you just count 1. 100 is 10 to power 2 because you count 1, you count 2. 1,000 is 10 to power 3, just following the same manner that we have counted above. 1,000,000 is 10 to power 6. And the number that is less than 1, you start counting from left. So this is 10 to power minus 8. This one, you count 1, you count 2, you count 3, and you count 4. So this will then be 10 to power minus 4. And 0.1 will be 10 to power minus 1 because you counted just 1. And because the number is less than 1, you are giving it a negative sign. But when the number is greater than 1, the exponent will carry a positive sign. Right, so this is where I'm gonna stop for today's lecture. Please like this video and subscribe, and I'm gonna see you in the next lecture. Bye-bye.